Okay, part 2 of our video. I'm on page 3 of our review, our test review. Number 9 is a polynomial in standard form. When an equation is in standard form, we pay attention to that first exponent only. That first exponent, which should be the highest exponent, tells you what the degree of your polynomial is. Now, it's time to pay attention to the leading coefficient, which in this case is the number in front, which you don't see, which is 1. So if I have 4, that's an even polynomial. If it's 1 in front of the x to the 4th power, so the leading coefficient is positive because it's a positive 1. Remember, I'm going to compare the end behavior to a right side up parabola, and those arrows both are pointing to positive infinity. So as I read my end behavior, this says as x approaches negative infinity, meaning as I go this way, the left arrow points towards positive infinity, so that f of x also approaches positive infinity. On this end behavior, where it says as x approaches positive infinity, this arrow also points up, so y or f of x is also going to positive infinity. For number 10, this polynomial is in factored form. And while we're at it, this one is also in factored form. When our polynomials are in factored form, we are adding the exponents. Looking at number 10, x is to the 2nd power over here, but this x should not be raised to the 1st power. Outside of the factor is where you see the exponent. So if I'm adding to get the degree, x was raised to the power of 2, x plus 3 was raised to the power of 1. Together, those exponents add up to 3. So it's a 3rd degree equation. The number or leading coefficient in front of the x squared term, the leading coefficient is negative. So 3 is an odd number. Negative 2 is a negative number. And so this function, this odd function, is going to be compared to a line with a negative slope. Notice, as I approach from the left, my arrow is pointing up, and so f of x approaches positive infinity. As I approach x from heading towards the right, that arrow is pointing down. So on the right, it's negative infinity. For our next polynomial, I'm going to add the exponents again. It's 2 plus the 1 you don't see. 2 plus 2 makes it a 5th degree equation. This function also has no coefficient in front, so the coefficient you don't see in front is 1. So this is odd positive. Odd positive is compared to a line. The end behavior is the same as a line with a positive slope. So on the left, as I approach negative infinity, y also approaches negative infinity. As x approaches positive infinity, I'm moving to the right. That arrow is pointing up, so on the right, it's positive infinity. Number 12, consider the function below. Identify each interval in the table to the right as increasing, decreasing, or constant. Remember, we are not worrying about constant, but we are worrying about increasing, decreasing, and we're going to mark that with our highlighter from negative infinity until this x value down here. This x value down here. The function is decreasing, and what we want to do is we want to figure out what the x value is for that minimum. So it's -1, -2, -3. So our function decreases from -infinity to -3, and then increases, I'm just going to use a different color highlighter, from -3 until this x value for that maximum. That x value happens to be +1. And I am decreasing again, starting at, that was supposed to be blue, starting at 1 and stops decreasing at 1, 2, 3, looks like +4. And then from +4, again, is going to be increasing. So I'm going to match up from 1 to 4, which is this purple here. It looks like my finger or pen would go down between those two x values, so it's decreasing. Greater than 4 is all of these values that are to the right of x equals 4. To the right of x equals 4, my finger or pen is going up. That is going to be an increasing part of the function. Less than -3 is over here. To the left of x equals -3, my finger as I move from left to right is going down, decreasing. Between -3 and 1 is this yellow part here. As I move from left to right, I am going up, which is increasing. So these are the values of my table. Number 13. Use the factored form of the equation to answer the following questions. Identify the zeros means identify all of the x-intercepts or solutions. For number 13, what we can do is take our equation, which is already in factored form, and set it equal to 0. Remember, x minus 2 raised to the second power is x minus 2 times x minus 2. Set equal to 0. I've got 3 solutions. X equals 4 is the first x-intercept, or 0. So if I'm going to make a list, I'm going to say +4 is my first 0. X minus 2 means the solution is x equals 2. And this solution is also x equals 2. So I'm going to list those 2 zeros. Now, these two functions, x equals 2 and x equals 2, they appear twice. If x equals 2 appears twice, we say the multiplicity is 2. And what that means is, for our graph, that it's going to touch the x-axis in a very specific way. So start with graphing 4 and start with graphing +2. My function, I have to determine odd, even, positive, negative. The leading coefficient I don't see in front is 1. The degree of this equation is going to be 3. X minus 4 is raised to the first power. X minus 2 squared is raised to the second power. So the degree equals 3. So it's going to be odd, and the 1 in front of the whole equation makes it positive. So I'm going to compare the end behavior to a line with a positive slope. That means over here, my function is going to be going up, and down here, my function is going to be going down. These x-intercepts and the multiplicity of 2 that occurs at x equals 2 tells me what my graph looks like. At x equals 2, because the multiplicity is 2, I touch 2, I turn around. That's what multiplicity of 2 means. And then since I have to go through to do the x-intercept of x equals 4, After I turn around, I must turn around again and head up so that my end behavior is the same as our line with a positive slope. The last thing that we have to do, we did x-intercepts and end behavior, is we must do the y-intercept. If I plug x equals 0 into my calculator, that means that I put my function x minus 4 times x minus 2 whole thing squared into y1, and I hit the trace button. My calculator is going to say that my y-intercept is 0, negative 16. So for my y-intercept, if I don't have any values on the y-axis, I'm going to label the 1 point on the y-axis negative 16, and then that would be considered a complete graph. Okay, getting late, but continuing on. Number 14. Remember, the leading coefficient is what tells us about whether we're positive or negative. In this case, 0.2 is positive. And then this x is 1. This x is 3. So the degree is going to be 4. So it's going to be even. That tells me for this function, the end behavior for both the left and the right is going to be towards positive infinity. That's going to help me do my graph in a minute. For my zeros, I'm going to look at the factored form of the equation, and I'm going to see that I have x here. So 1 x-intercept is going to be 0. The other x-intercept is going to be negative 5. Now, my question becomes multiplicity. Multiplicity has to do with how many times an x-intercept or 0 appears. For negative 5, it's going to be multiplicity of 3. And I know that because the exponent is 3. The only other thing I need is my y-intercept. In my calculator, if I put 0.2x times parentheses x plus 5, close parentheses raised to the third power, and I'm trying to find the y-intercept, after putting that equation in y1, I'm going to go to the trace button, hit 0, and then my calculator is going to say, well, the y value is also 0. So graphing this function, here is our x-intercept, also our y-intercept at 0, 0. Our other intercept is going to be at x equals negative 5. The end behavior tells me at the very end it's going to be up and up. And the multiplicity at negative 5 tells me that the way the graph looks, I kind of curve in. I'm going to try that one more time to make it look a little pretty. My whole computer slid a little bit. So here I'm going to try it again. I'm going down. I'm sliding in. I'm flattening over here a little bit so it looks like a cubic. And then I'm continuing down. Now, my x-intercept is 0. So sometime after going through this with a little wiggle, I am going to turn around back up and go through x equals 0. I don't think this is a very good looking graph, but it has everything you would need to do what's called a rough sketch. You have your x-intercepts, which are negative 5 and 0. You have your end behavior both facing up like an even parabola. And then you have your y-intercept. And for the multiplicity of 3, you have your head towards the x-intercept and flattening and continuing down. Number 15 is also in factored form. X plus 2 is to the first. X plus 1 is to the first. X minus 4 is to the first. X minus 1 is to the first power. So our degree of the equation is going to be 4, 1 plus 1 plus 1 plus 1. Our leading coefficient is 1, so this is